This problem is 1.10.18 from the textbook. And it's talking about you want to draw a random sample of 10 fibers from this total 92 fibers. 43 of the fibers are polymer A, 17 are polymer B, 32 are polymer C. And A asks, what is the probability that no fibers are polymer B? Now, most of this problem we're going to use section 1.7, the combinations, but we don't actually need to on A. We could do this using just our basic probability rules. So if we want the probability that no fibers are polymer B, we can say, well, what's the probability of no B fibers? Well, this would be the probability of the first not B, and the second not B, and dot dot dot, and the 10th not B. Well, let's see, to calculate this then, we would have, there are 43 plus 32, 75 not B fibers. Okay. So for my first draw, there are 75 out of a total of 92 not B fibers. And then I need the second one to be not B, but I don't have 75 not B fibers anymore. I only have 74 out of a total of 91. And then the next time I only have 73 out of a total of 90. And you need to do this 10 times, so our last one will be 66 out of 83, which gives me 0.115. So again, this is just using all of our old methods. Just sit down, you can figure it out. Or method 2, use combinations, and we're going to use combinations instead of permutations because the order doesn't matter. And this is in section 1.7. And so if we're looking for the probability of no B fibers, we say, okay, how many ways can I get a sample of 10 not B fibers? Let's see. So let me actually write this out. Number of ways to get a sample of 10 not B fibers. Okay. Out of the total number of samples. Of size 10. So how many ways to get what we want out of the grand total? Well, if you think about this, how many ways can you get a sample of 10 not B fibers? So we want to choose 10. So we'll do a combination. We want to choose 10. And how many not B fibers are there to choose from? There are 75. Now, what are your total number of samples of size 10? Well, again, we want to choose 10, but if we're just talking about all possible samples, there are 92 fibers to choose from. Okay, you can put this in your calculator. You can use the alternative notation of 75 choose 10, 92 choose 10, and this will give you 0.115. So let's make ourselves a note here. That the total number of possible samples of size 10 is 92 choose 10. Or, if I was to write in a rotation, so this would be 92 to choose 10. Because we're going to use that for the rest of our problems. Okay, now part B. Now we want the probability that we have exactly one fiber of polymer B. There are a few different ways we could do this problem. At this point, if we've learned about binomial probabilities, you could use the binomial probability for this. If we were trying to use just our basic probability rules, what you'd have to do is you'd have to draw out a tree diagram to list out all of your possible combinations. So you could say your first one is either B or not B. And then your next one is either B or not B. And this one could be B or not B, etc. And you'd have to do that 10 times. And then at the end, you can go through it and you can say, okay, which of these combinations have exactly one B, and add up all of those. But for 10 times, this is going to give you over 1,000 different outcomes to look at. There's no way you want to do this by hand. Okay. So you either have to use the binomial distribution, or since we haven't learned the binomial distribution at this point in the textbook, we can use combinations. So what I'm going to do here is I'm going to say, how many ways can I get exactly one fiber of B? Well, how many ways can you get exactly one fiber of B? You need your first, well, you need one fiber, it doesn't matter which one. So you need 1 to be B, and you need 9 to be not B. So let's think about this. How many ways can I choose my one B fiber? Now there are, if we look at this, back up at the top, 17 B fibers. So how many ways can you choose that one B? There are 17 fibers. I need to choose one of them to get my B. Then times, because it's an and, now I need to get 9 fibers that are not B. So there are, again, are 75 not B fibers, and I need to choose 9 of them. So that's how many ways I can get exactly one fiber of B. But we weren't looking for how many ways, we were looking for the probability. So the probability of exactly one B would be the number of ways to get exactly one B. So 17 choose 1 times 75 choose 9 divided by our total number of possible samples of size 10, which is 92 choose 10. We can put this into our calculator and we get 0.296. And we're going to follow the exact same logic for part C. So we're looking for the probability of 3A, 3B, and 4C. So we need to get 3A and 3B and 4C. So we're going to follow that same method. So first for the numerator, how many ways can I get exactly, or how many ways can I get 3 A's? Well, how many A's do you have to choose from? You have 43 A's to choose from, and you need to choose 3 of the A's. Okay. And then for the B's, you have 17 B's to choose from, and you need to choose 3 of them. For the C's, you have 32 C's to choose from, and you need to choose 4 of them. And the grand total of possible samples you can get of any possible samples is 92 to choose 10. And this gives me 0.042. Let's just come back and remind ourselves what each of these are. So this gives me my 3 A's. This gives me my 3 B's, and this gives me 4 C's. And this is just gives me a sample of 10 fibers. You don't care anything about what type of fiber, just the grand total of number of ways you can pick 10 fibers.